So this is a quick refresher on 6.7, which are our inverse functions. And you seem to be trying to complete the remediation for this because you look like you're doing a retake. So I'm going to do a couple of each kind. I just want you to make sure that you know exactly how to do all of these on your own. And the first part says they want you to find the inverse of the function. So remember, function notation, this h of x or g of x in this case, really just a fancy way of saying y. So your first step in all of these questions is to switch the x and y. So I'm going to do that. I'm going to rewrite it as x equals negative 8y plus 3. And then your second step would be to solve for y. In other words, to isolate the y. So right here, if I tried to isolate that y, I would first subtract a 3 from both sides. Oops, that's crooked. You get an x minus 3 equals negative 8y. And then final step here, I divide everything by negative 8. Now the notation of what your answer looks like and what the key looks like on the back, we could have different answers, of course, as long as they're equivalent. But I need you to give this the proper name. So this original function was called h of x, if I believe, which means my inverse function is going to be the inverse of h of x. So h to the negative 1 of x equals, and then of course I could simplify that, 1 divided by negative 8, so that coefficient on the x is really a negative 1/8 x. And then negative 3 divided by negative 8, the fraction doesn't reduce, but the double negatives would simplify to a positive. So this is one version of the inverse function. If you had it all over 8, that's still technically all correct. Just watch your signs. Now on number 3, you're going to see something kind of unusual happen. So again, remember g of x is just fancy talk for y. So when you switch the x and y around, you end up with this. And then if I go to solve for y, right now everything's kind of trapped in our proportion, so I'm going to cross multiply. So x times y, better known as xy. And then negative 2 times 1 is just a negative 2. So now when I go to solve for y, which is right here, my next step would be to divide by x. And I feel like, you know, maybe at first glance you're thinking, man, I screwed that up, because you end up with the same function again. There are some functions where they are their own inverse. So right now I would have y equals negative 2 over x, but I'm going to save myself some time. I'm going to give this the proper name. Remember, the original function was g of x, so his inverse function is g inverse of x equals negative 2 over x. Anytime you get these rational functions that don't have any transformations on them, like right or left or up or down, they are their own inverse because they are very special functions. If you don't notice it, it's not the end of the world. Now on the next section of your remediation, they want you to graph the original and also graph the inverse. And what you're going to see is they are reflections over the line y equals x. So the line y equals x is supposed to connect through the origin, slope of 1. This is our line of symmetry between two inverses, an inverse and its original function. If I were to graph 2n minus 2, so I'm going to graph this guy in blue, it would start at negative 2. And then your slope would be, up to right 1. Man, this is way too small for me, guys. And you know, I don't graph so hot, but you know, hope for the best. So there's our blue function. Now the inverse function, I would have to find, or I'd have to do some switching of ordered pairs. So after you use your skills from above, where you switch the x and y around, you end up with a new function, which we know is the name of g inverse. So I want you to practice finding inverses on your own there, guys. And you're going to end up with the line, let's see, what does that come out to? 1, 2. So 1/2 x plus 1. And if I were to go graph that line, okay, again, pretend I can graph a line straight. You're going to see this reflection, the line of symmetry, along the y equals x. So this is a good double check for when you find inverses and you graph them up against their originals. If you don't see that symmetry along the line y equals x, that means you've messed something up. And then the 5 properties, including the tests that we're going to use. Let's see. So, first main property, x and y switch. And then because the x and y switch, that means the domain and the range switch. the third property we just saw up here on number 5, the original and the inverse reflect over the line y equals x. I apologize for my horrible handwriting. My goodness, this is extra bad. And then another important thing, and this is the test they're referring to. Let's talk about the 4 properties here. There is a 5th one, but we don't talk about the composition property, and that's okay. If the original passes the horizontal line test. Okay, so if the original passes the horizontal line test, then the inverse is a function. The idea behind that property is that if the original passes the horizontal line test, that means the other guy, the inverse, would pass the vertical line test, and we know that as to be one of the things that indicate whether things are functions or not. So there's going to be a question on your retake where you have to kind of utilize those properties, so make sure you're familiar with them and what they actually mean. Don't just be able to like spout them off, but like what do they actually mean. Alright, good luck on your retake.